So the today topic is gear analysis of polymer composites gear. The gear drive is a mechanical elements that transmit power throughout the tooth wheels per helical, bevel, worm, and a lot of gears is available. So the testing methods, if we made a testing rig, more than 1 lakh cost estimations, but we conduct the test by using the central lathe. A central lathe developed in the laboratory to conduct the performance of nylon 6 polymer composites gear. The polymer composites gears per gear was driven by a steel gear with a maximum 2787 rpm and transmit power to the steel gear. This runs constant at 1440 rpm. Table number 5, the gear test specimen specifications are given in table number 3.3. All tests were conducted unlubricated conditions. From the literature 2019, it observed the wear rate acetal gear record the torque of 7 Newton to 16 Newton. These are the setup for wear test analysis of polymers gears. These are the sample testing gears. Gear test conditions: torque 2.5, 4.1, 7.4 and 10.17. We conduct the test torque in the lathe. The rotational speed 1440 rpm. Lubricant drive. Testing gear polymer matrix composites gear. Matting gear steel gear. The first one is a measurement of temperatures. The temperature of gear tooth surface was measured with the use of infrared thermometer. The thermometer lens was focused upon the gear tooth surface to detector, converting the radiant power into signal that displayed in the temperature units after ambient temperature is compensated. This configurations make if particle measure the temperature from the distance without contacting objects. Every 0.10 into 10 power cycles gearing is measured. First, the temperatures affect 2.5 Newton. The tooth temperature under the 2.5 Newton, torque increased slowly. The beginning experiment for all gears shown in 5.3. The later in the experiment, the tooth temperature reached the thermal balance and the temperature stabilized with both gears. For all gears, 1.0 into 10 power 6 revolution slightly damaged the tooth surface 2.5 Newton level. These are the graphs for the 2.5 Newtons load acting in polymers gears. The identified red colors is 20% of glass fiber with nylon 6. The black color 30% weight ratio of nylon 6 with glass fibers. The maximum cycle durations 1.2. The temperatures 36. So next one is the effect of temperature 4.1 shown in figure 5.4. The tooth surface temperature rapidly increased compared with the previous load. The tooth surface temperature of polymer gear 4.1 Newton is higher than the order of 2 ratio of gear completed 0.5 into 10 power 6 revolutions with the minor debris formed in gear tooth. It's observed that both different gears 0.86 into 1.6 revolutions respectively. From this data, it clearly indicates the increasing the torque level lead to increasing the temperatures of gears. With increasing the torque level, both gears were rapid increase in the temperatures in gears, which lead to softening of material. It can be explained the material suffer plastic deformation severe relatively high loads. This lead to decrease the mechanical strength of these materials. 4.1 Newton loads. The test duration cycles, temperatures maximum 46. Next one is the temperature effect of 7.4 Newton and 10.7 Newton respectively, shown in figures. The maximum temperatures reach 50 degrees Celsius. The torque 1. The overall surface to temperature of glass subjected to 7.4 Newton and 10.4 Newton level increased compared the torque of 4.4 Newton per meter. Increasing load of these gears rapidly increasing the tooth temperatures, which lead to softening material. So the plastic deformation is recorded and finally tooth surface changed. The temperature effect of both of ratio of PMC gears shown in figures. Next one is a 10.17 the consolidated temperatures results. The comparing the average tooth surface temperatures gears at various level, it observes the average of 80% nylon 6 blended with the glass fiber and 70% glass fiber ratio both gear mat with steel gears. It's clearly that temperature increased with increasing the torque level of gears, also gear fiber increasing the thermal stability. The average tooth surface temperature of both gear responsible for thermal softening, which regions comparatively the more material softening occur for both gears, especially 7.04 Newton meter and 10.17 Newton meter torque level.